So in this video, we're going to be discussing how do we solve and graph two variable inequalities. So first of all, we got to remember that now that we have an x and a y instead of just an x, well, this is going to make a relationship between the x and the y, and it's going to make a function, which is a linear function, since we don't have any squares and it's just x and a y. What we're going to be doing is basically now we're going to be graphing a line on the coordinate grid. And then, of course, we're going to still be shading on one side or the other because it's an inequality. So let's talk about the four different types of symbols I can have for my inequality. So we can talk about the type of line that we would draw and also the shading. Okay, so first of all, I can have less than or equal to, I can have greater than or greater than or equal to. All right, if I have less than, then that means your solution cannot be equal to the value. So when we were doing it on the line, if you remember, we would do an open circle. So now that we're doing it on the coordinate grid and we're drawing a line, well, we're going to draw a dotted or a dashed line. So that's what that's going to look like. And if my line has a positive slope, it's going to look like this. And if my line has a negative slope, it's going to look like this. Okay, now, if I have a less than or equal to, then that means that I can be a solution that is on the line. So we can have a solid line. And again, if it has a positive slope, it's going to be a line that's going up. And if the line has a negative slope, it's going to be a line that's going down. Now for greater than, since it does not have the equal sign, that means you cannot be a solution on the line. We would do a dotted line again. So it's a line going up if it has a positive slope and a line going down if it's negative. And if it's greater than or equal to, that means your solution can be on the line and we can have a solid line. So up or down. It doesn't really matter it really depends on the slope. Okay, so now the shading is also going to be dependent on the symbol. So if it's just less than, then that means that we are going to shade on the bottom, right, of the graph, whatever is less than. So if we're thinking of less than, your goal is basically to have everything, let's make this just a little bit smaller, everything on the bottom of the graph of the line, and the line is the top part. So this is where I would shade in this case. Here again, this is my line, and I want the line to be the top of everything, and I want to shade under it because it's less than. So this is what under would look like. Okay, now for less than or equal to, the shading is pretty much the same. I can be on the line, but I can also be below it. So we're going to shade below. And again, below this line would look like this. Try to shade the best way we can. All right, now for greater than, we want to shade on top of the line. So I would shade above the line. Again, above the line on here would look like this. And for greater than or equal to, yes, you can be on the line, but again, you would still shade above as well because you can be greater than or equal to. And so we're going to use this key to refer back to when we are shading and making our lines. So notice that for greater than and greater than or equal to, the shading still remains the same. The only difference is the type of line. Same thing for less than. The less than remains the same, which is kind of the opposite of greater than, but the line will be dependent on whether you have the equal sign or not. Okay, so now let's go ahead and make our key for the type of line. Remember that if I am less than or greater than and don't have an equal sign, we're going to have a dotted or dashed. So let's go ahead and say dashed. If you have the equal sign, then you're going to be a solid line. So in this case, we have to graph y is greater than 2/3 x plus 2. So the first thing we have to do is we have to graph our boundary line, which is y equals 2/3 x plus 2. If we were graphing that line, the first thing we would do is graph the y-intercept, because that is a point. We would get our other points by using the slope. The slope says that I need to go up 2 over 3. Here's another point. And we can get another point this way by going down 2, backwards 3. Now I have to decide what type of line. Well, this does not have an equal sign, so I need to go ahead and do a dashed line. So we're going to look here for our dashed line, and we're going to create a dashed line. So if you have a ruler, I would go ahead and take a ruler, make sure that the line goes throughout the entire graph. Okay, now all I have to do is shade. So let's look at this symbol. This symbol that's here says that y is greater. So that means I have to shade all of the points that are above this line. So above this line would look up here. So if we looked at our key that we made appear, right, greater than, again, would be up here for something that has a positive slope. So it looks pretty similar. Now I always suggest take a point. It's in your shaded area, plug it in, and make sure it works. If it doesn't work, that means that you shaded on the wrong side. You have to shade on the other side. And so here, let's pick a point here. This point is 0, 5. So we're going to go ahead and plug in 0, 5. That means that x is 0, the y is 5. If I plug that in, I'm going to have 5 is greater than 2/3, parentheses 0 plus 2. This will go away. 5 is greater than 2, which it works. I always suggest to take a point that's on the y-axis or on the x-axis because that'll make something 0 in your equation, and it's just easier to work with everything. Okay, so in my next graph here, I have that y has to be greater than or equal to negative 3x plus 4. So first we have to graph our line y equals negative 3x plus 4. So we're going to do that by first graphing the y-intercept. And then our slope is negative 3. So that means I'm going down 3 over 1. So down 3 over 1, down 3 over 1. Okay, now we have to decide what type of line we want. Do we want a solid line or a dashed line? Well, it has an equal sign, so we want a solid line. So let's go ahead and pick solid and make a line through here. Obviously, if you have a ruler, go ahead and do that, or just a straight edge. And then now we have to shade. It says greater than, so I need to shade above this line. So because this has a negative slope above, looks slightly different than this, it's still the same idea. I need to be on top of the line. And so again, looking at my key here, greater than or equal to, on top when you had a negative slope look like that, and so this pretty much matches that. Okay, so now go ahead and pick a point. Again, we want to pick a point that's maybe on the x-axis or on the y-axis. Let's pick a point up here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So 0, 8. So that means I'm plugging in a 0 for x and an 8 for y. So y has to be greater than negative 3 times 0 plus 4. Well, this would cancel, and we would be left with 8 is greater than 4. So great, that works out just right. That is true, and so we have shaded in the correct area. Okay, now in this example is slightly more difficult because it's in standard form. So that means I need to solve this out for y and then go ahead and graph it. So the first thing that we're going to do here is we're going to move over this positive 3x and move it over this way. So we're going to subtract 3x from both sides, and we're going to get negative 2y is greater than 6 minus 3x. And then we're going to divide both sides by negative 2. Now, here we want to be careful. We got to stop. We're dividing by a negative number. And just like before, the rule still applies to inequalities. We have to flip our sign. So, we're going to do y is less than 6 divided by negative 2 is negative 3. And then here my slope here, a negative 3 divided by a negative 2 is a positive 3 over 2x. So just be careful. We had to flip that sign here, and that's what usually a lot of people forget to do. So now let's go ahead and graph this. My y-intercept's -3. My slope goes up 3 over 2, up 3 over 2. And then let's make a line. This does not have an equal sign, so that means I need a dashed line. And so here you go. And then again, we need to make sure we're shading in the correct place. It's less than, so that means I'm shading below. And that's where people would mess up if they forget to change the sign. So that's why plugging in a number is always good. All right, let's take a number here that's again on the y-axis. Actually, let's take one on the x-axis this time. So let's take this point right here. So that would be 1, 2, 3, 4, 5, 6. So 6, 0. Let's plug that in. I always suggest plug into your original, just in case you forgot to change that sign. So here, this would be 3 times 6 minus 2 times 0, and that has to be greater than 6. Well, this would cancel out because it's 0, and so 3 times 6 is 18, which is greater than 6. Good, I shaded in the right place. If I were to plug in a point and it didn't work, that means you forgot to change the sign or something and you shaded in the wrong place. Well, it's a 50-50 chance. Shade in the other place. And so now here, we need to go ahead and solve this again for x. And so we would have 3y is less than or equal to 6 minus x. When I move that x over, divide both sides by 3. And we would get y is less than or equal to 6 over 3, which is 2, minus, again, what is my slope here when I have a negative x over 3? Well, I have a 1 over 3. That is my slope, negative 1/3 x. Let's go ahead and put that y-intercept. Let's go down 1 over 3, down 1 over 3. Okay, so what type of line do we need? It has an equal sign, so that means I need a solid line. Need a solid line here. And then where are we shading? Well, we have to shade below here because it's less than or equal to. So we're shading below our line. All right, now pick a point here. So let's pick an easy point, 0, 0, and just check that it works in your original. If I plugged in a 0 plus 3 times 0 is less than or equal to 6, well, all of this is 0. Is 0 less than or equal to 6? Yes, it's good. And then these last two examples are kind of special type of lines that we've gone over. So first we would have to graph here y equals 3. So remember we have to graph where it cuts through 3. And there is no equal sign, so I would do a dashed line on here. So y equals 3 would basically look like a horizontal line, and it needs to be dashed because you don't want to be equal to here. You just want to be greater than. Where is greater than in this case? Well, above. Above the line is up here. And so pick a point. If we pick a point, especially on the y-axis, it's a little bit easier to see. Let's say we pick this point, which is 0, 5. Well, there's no x in my equation. Just the only thing that matters here is the y. Is 5 greater than 3? Yeah. So good, as long as the y is bigger than 3, it satisfies the inequality. Now for x equals, we're doing basically the same thing we were graphing last time on the number line, but we're graphing this on a kind of like a two-dimensional graph instead of just a number line. Now we have an x and a y, but it's pretty much the same thing. X is equal to -4, well, again on the number line, right, would be right here, -4. So I'm going to draw a line that cuts through that, and it needs to be equal to because there's an equal sign. And where am I shading? Well, where did I shade when it was a number line? If I want to be less than, I would shade to the left. So, and again, we can take a point and plug it in. So let's take a point that's right here on the x-axis. If we have -5, 0. Again, the only thing that matters is the x for my equation. So is -5 less than or equal to -4? Yes. this was the number line, right? We would just be looking at this part. Same idea, just looks a little bit different because we have an x and a y in this graph. All right, so that is the end of this video, and I hope that you found this helpful with how to solve and graph two variable linear inequalities.